Okay, today we're going to talk about graphing linear inequalities. Earlier this year, we've graphed linear inequalities that were written in one variable, and we did that on a number line. So what we're going to do today is we're going to graph linear inequalities, but we're going to graph these on the coordinate plane. And in order to graph on the coordinate plane, we're going to be using slope and y-intercept. Okay, the first step to graphing the linear inequalities is to write the inequality in slope-intercept form. And you remember that slope-intercept form is y equals mx plus b, where m is the slope and b is your y-intercept. Okay, so your first step is to write the inequality in slope-intercept form. So we want our equation, or our inequality in this case, to be y equals mx plus b. That's the form we want. And remember that m is your slope and b is your y-intercept. Okay, you can also recall that we've defined slope as being rise over run. This top number tells us whether we're going to go up or down. The bottom number tells us whether we're going to go left or right. Okay, now when we were solving inequalities in one variable, there was something important we needed to remember. And we're going to have to remember that for these inequalities in two variables as well. Okay, and that's remember if you multiply or divide by a negative number, remember what we have to do? If you multiply or divide by a negative number, you must flip the inequality. Okay, so the first step, we're going to write the inequality in slope-intercept form. And when we're writing this inequality in slope-intercept form, if we multiply or divide by a negative number, then we've got to remember to flip that inequality. So let's take an inequality and let's practice. Okay, here's an example. Okay, my inequality is x minus 2y is greater than 8. X minus 2y is greater than 8. Now, to get this inequality in slope-intercept form, we need to isolate this y. To isolate the y, we're going to start by subtracting x from both sides. These will cancel, and that's going to leave us with negative 2y is greater than negative x plus 8. Now we need to divide each term by negative 2 so that the y is completely isolated. Since we're dividing by a negative, we have to remember to flip that inequality. And it gives me y is less than, two negatives here make a positive, 1/2 x, positive 8 divided by negative 2 is negative 4. So that's your slope-intercept form. Now, from this form, we know that our slope, m, is 1/2, and that means that we're going to go up 1 and right 2. Your y-intercept is negative 4. Okay, so that's the first step to solving or graphing your linear inequalities. So the first step is to put this inequality in the slope-intercept form. So that's nothing new. Your second step is to decide what type of line we're going to use to connect these points. Okay, now when we were solving the inequalities in one variables, we were using open circles and closed circles. If it was less than or greater than, that used to be an open circle. Now we're going to use a dashed line, or sometimes it's referred to as a broken line. You can kind of think about it this way. The circle was open, so your line now is going to be open. So there's going to be space between the lines when you connect the points. So that's what your dashed line looks like. All right. Your second option here is if I have less than or equal to or greater than or equal to, then we're going to have a solid line. A solid line is a lot like a closed circle. There's no space. There's no opening. So that's your solid line. So after you've plotted your y-intercept and you've used your slope to get other points on the line, then we're going to decide if we're going to use a dashed line or a solid line. If the inequality is less than or greater than, we're going to use a dashed line. If it's less than or equal to, greater than or equal to, we're going to use a solid line. The only difference here is the solid line, the inequality will have the line up under it, which means it can be equal to. So points on this line will satisfy the graph. Points on a broken line will not satisfy the graph because will not satisfy the inequality because it's not equal to. All right, so now we're 2/3 of the way done. After you've put your inequality in slope-intercept form and you have graphed the line, you've plotted your points using the slope and the y-intercept, and you've chosen the correct line to use, then the last decision that we have to make is we've got to determine how to shade the graph. Okay, so your third step is shading the graph. All right. So then we're going to shade the graph. Now, when we're shading the graph, okay, we can have a lot of different lines. We can have a horizontal line, and a horizontal line, this is above the line, and this is below the line. We can have a vertical line. This is to the right, and this will be to the left. Remember, with the horizontal line, the equation is only going to have the variable y. So like if you have y is greater than 3, that would give us a horizontal line. With the vertical line, you're only going to have an x. So if you have x is less than or equal to 2, that would give us a vertical line. Then we can have a line that has a positive slope. Then this is above, and here's below. Or we can have a line that has a negative slope, and here's above and below. So these are the 4 different type of graphs that we can have. Now, to determine how to shade, you're going to focus in on the inequality itself. Okay? If we have y is less than or equal to, x is less than or equal to, then we're going to shade. Okay, here we're going to shade below or left. Because it says less than, below the origin or negative numbers, to the left of the origin are negative numbers. So those are your numbers that are typically less than. If you have y is greater than, y is greater than or equal to, x is greater than, x is greater than or equal to, we're going to shade above or to the right. Okay, so if it's greater, that means more. Above, positive numbers are above the origin, and to the right, positive numbers are to the right of the origin. So that's your shading. So now what we're going to do is we're going to go back to the example that we started with in step 1. We're going to graph that and look at what the graph looks like after we shade. Okay, we started with the example x minus 2y is greater than 8. So we will first subtract x from both sides. And you already have this done in step 1. I'm just working through it again. And then we're going to divide each term by negative 2. All right, and then we have y, and we flip that inequality, less than 1/2 x minus 4. Okay, we decided that the slope was 1/2. The y-intercept is negative 4. Now, based on my inequality, let's decide the type of line. Okay, my inequality is less than. All right, this is the one we're going to use to determine how to shade. This is less than. There's no line up under it, so we're going to use a dashed or broken line, however you want to refer to it. Okay? And then we got to decide where to shade. Okay? It says less than. All right? It reads y is less than. All right? With less than, that means that we're going to shade below or left. Okay, so any questions about the type of line or the direction of shade? So if you have any questions, you make sure you make a note of those questions and we'll answer them when you get to class. All right, now let's draw the graph. All right, we have us a little coordinate plane here. We're going to start at the y-intercept of negative 4. Then we're going to go up 1, right 2 with our slope. Up 1, right 2. Down 1, left 2. We connect these points with the dashed line. And I'm going to shade below. Now, I want you to try these two problems before coming to class tomorrow. Number 1 is 2x minus 4y is less than or equal to 12. Number 2 is 2y plus 3 is less than 9.